This video is going to be explaining how to graph radical functions. So we're dealing with graphing radical functions. Vocabulary. We're going to have a radical function is any type of radical. So it's a function that can be written in the form of f of x equals the nth root of x minus h and then plus k, where a is not equal to 0. So that would be a times the nth root. Okay. For even values of n, the domain of a radical function is the real numbers of x is greater than or equal to h. That's the h value and larger. So this goes back to kind of like quadratics. Quadratics will go forever in both directions, left and right, which is why it's negative infinity to infinity. But radicals actually have a very specific domain because you cannot take the square root of a negative. So that means that anything that would make the radicand a negative would give you an error. So that means your domain, your x values can't be equal to that. So for here, and the range values would be the values from k, and depending on if you're going up and down. So again, your k value is the y values for your range, and this also tells you your transformations. So if we look at this example, this is technically a square root because our index is a 2. The h value, going back to like vertex form, we actually change the h value, but we keep the k value. So our key point would actually be at positive 2, 0. So that means that our domain, if we wrote our domain, it would actually be written as close bracket, positive 2, positive infinity, and then open bracket. Our range, since your transformations, it is not reflected, our range would go from our close bracket 0 up to positive infinity and then open bracket. So if we were to talk about our transformations, your a value is a positive and a positive 1. So there is no reflect, there is no stretch or compress, but our h value does go to the right 2, but it doesn't not go up or down. So on this one, we will still do it just like we did from vertex form. We would find the transformations the exact same way. And then our function notation for this, if we remember that, f of x would end up being f of x minus 2. Because what happens is this is still telling us that it's going right 2, but there's no reflect and no stretch. The square root symbol is what turns into the parentheses. It gives us the parentheses. So again, a square root function is just specifically going to be a square root. So we already kind of talked about that. So it's the a, the x, minus h, plus k, same thing we were just talking about. So on here, our key point, again, is from our vertex. It's that positive 3 because you have to change the h, but keep the k. So our vertex, or it's not actually our vertex this time, it's called our key point, would be at positive 3 and then positive 1. So because our a value is positive, that means that our range will still have a positive infinity. But our domain would be from a positive 3, so close bracket, positive 3 to positive infinity, open bracket. And our range, because our a is positive, we're going to have a positive infinity. And then our range are 1 from our key point. So our transformations here, because a is positive, that tells us there is no reflect. Our a is 2, that means we're still going to have a vertical stretch of 2. And because our key point was at 3, so we're going to go right 3. But then we're going to go up 1. Those are our transformations. And our function notation would go back to, like we've done before, the 2 is in front of the parent function, so it would be 2f of, and then we'd have x minus 3, close parentheses, and then plus 1. This is still telling us our a, our h, and our k, just for a specific radical function. So the families of radical functions, again, we have a parent function. So this is going with the transformations. The parent function is the square root of x. So anything that's changed from that is written in our function notation, because you see how the x is minusing 3, but that would go inside the parentheses with f of x. And then if it's added 1 to the outside, it'd be added 1 to the outside of the parentheses. We still have the reflect over the x-axis if your a is negative. We still have a vertical stretch and a vertical shrink if we have our a is bigger than 1 or a is smaller than 1. And then we still have translation, so we're going left and right by the h and then up and down by the k. So that's still normal. The same thing happens with any type of radical. So if it's a cubed root, fourth root, fifth root, any type of nth root, you follow the exact same notation. So your transformations are still the same that we've always been doing. And our function notation would still be the same as in f of x. It's just that this would be an nth root of x, which won't change the function notation itself. So if we want to go in and actually graph some radicals, so translating the square root function vertically, what you want to do is you want to first find your key point. So your key point is basically like from that vertex. Key point is the h value, which is, there's nothing in there, that's 0, comma, and then you keep your k. And another thing you can do is you can actually just graph this. So if we turn on our calculator, we go to our y equals, we can just graph this. It's the square root of x, but you have to close your parentheses and then plus 2. We're going to go to zoom 6. This is what our graph looks like because we can't take the square root of negatives, which is why those aren't over there. So we go to second table, and we just get our coordinates. So here's our key point. The first coordinate that doesn't have an error is your key point. So 0, 2. And that's what it looks like because it was change h, keep k. So we write down our coordinates, 0, 2, and then we write down some other ones that are good. So 0, 2, 1, 3 is good. 4, 4 is good. See if there's any other ones. 9, 5 is good. Now if you look at your graph, we have our x on the right and our y on the top, but it's only counting, they're counting by ones, it only goes up to 7. So we won't be able to graph all of these. We want to graph as many as you can. So the first point you graph is 0, 2. So 0, 2. 1, 3. 4, 4. And then 9, 5 is way out here, so I know I can't graph that. But I know that my graph can't come over here because those were all errors. So I have to start here and then make my radical go this way. So if we think about our domain is everything that's greater than your h value. So your domain is starting, your x value is starting at 0, close, and it's going to the right. So that's a positive infinity, open bracket. Our range, because it's a positive, it's going to go up. So that means that we're going to have a positive infinity. And our range starts from also your key point, which is 2. So close bracket, open bracket. And as you can see, this would just be, if I were to graph just the parent function of y equals the square root of x, there is the one that we just did. Here's the original. All this is just translating this up 2 spaces. All the coordinates are being moved up 2 spaces, and that's all it is. So the transformations, we always want to make sure we know the transformations. Are, since a is positive and it's positive 1, so a equals positive, a equals 1, h equals 0, and k equals 2. So there's no reflect, no stretch, compress, and it does not go right or left, it just goes up 2. And that's what's happening. It's going from 0, 0 up 2. And so if we wanted to write it as a function notation, we would have f of x plus 2. That would be function notation. For example 3, we can do the same thing. We can graph it and get our coordinates for our table. But you always want to try and get your key point just to see where it should probably start on your table. So that will be helpful to you. So our key point for this one would be your h is 0 and your k is negative 3. So if we were to graph this one, if we go to y equals, and we graph the square root of x, close parentheses, minus 3, and it looks like we're starting at 0 and then negative 3. So if we go to our table, 0, negative 3 is there, and then everything above that on the table is actually at an error. So that makes sense because that would be our key point. That's our starting point. So we would start with 0, negative 3, and then we would do 1, negative 2. Go down, find some other good ones. 4, negative 1. Then 9, 0 is another good one. But again, our graph only goes up to 7 and to 6, so that means that this is probably as much as we can have. So if we graph this, 0, negative 3 is our first one. 1, negative 2 is our next one. 4, negative 1. And then we'd have 9, 0, which is way over here. So we can go ahead and graph this. Again, we don't have anything over here because that's an error. So we start here as our key point. That's our start point. And we just connect and we just keep on going. So again, talking about your domain and range. Talking about the domain and range. Your domain starts with your h value. And it's going to the right. So there's a positive infinity. But there's a 0 for the x. And then close bracket, open bracket. For the range, it's also going up, so that's a positive infinity. And then your y value is where it starts. So negative 3, close, and then open. So if we talk about our transformations, so again, we talk about our a value. So a, I'm going to write over here, a equals positive, a equals 1, h equals 0, and k equals negative 3. So that means there's no reflect, there's no stretch or compress. It's from those two. It does not go left or right, but it does go down 3. And if we were to talk about the function notation, we would write it as f of x. There's nothing inside with it, so we'd close parentheses and then minus 3. That's just telling us that the function is going down 3. So if we do these over here, we want to find, again, our key point. Key point, you always try and find your key point first. Your key point is also your starting point. So you look at your h and your k. Remember, you change your h, so that's actually at a negative 2, comma, and then your k is 0. So that should be our key point, and if we go into our y equals and we graph that, so the square root of x plus 2, both the x plus 2 is inside your radical. We graph this. So it's at negative 2, 0, and that looks like it's at negative 2, 0. So if we go and look at our table, negative 2, 0 is a coordinate, and then everything else is an error above that, so that was correct. So then we would start with negative 2, 0 on our coordinates. So negative 2, 0, negative 1, 1, find some good ones, 2, 2, 7, 3. I think that's going to be all we can find to put on our graph. So if we graph these, we have negative 2, 0, negative 1, positive 1, 2, positive 2, and then 7, positive 3. So again, we have a starting point, so this is where we start at. We can't go anywhere over here. Starting here, and then we connect our dots, connect our coordinates. So again, talking about your domain. Your domain is going to the right, so that means it's going to have a positive infinity. And it starts at that negative 2 as your x value, so negative 2 as a close bracket, and then an open bracket. Your range is pointing up, so that means you're going to have a positive infinity. And then your y value for that key point is 0, close bracket, open bracket. So then next we want to talk about the transformations. And again, we talk about our A equals a positive, A equals a 1, H equals a negative 2, and K equals 0. Because that's from the key point, positive 1 comes from here. That means that there is no reflect, there is no stretch or compress. We go left 2, and if you look at the graph from 0, 0, it went left 2. But it does not go up and down from 0, 0, it did not go up or down. So that makes sense. And then for our function notation, we would write it as f of x, and then because the plus 2 is inside with the x, it would be plus 2 inside with the x. That's our function notation. This next one is y equals x, square root of x minus 3. So again, we're going to try to find our key point. Key point is key point. You change your h, which gives us a positive 3, and then our k is 0. So again, if we go to our y equals and graph this, this is square root of x minus 3. And we graph. So it's at positive 3 comma 0, which is what we thought it would be at. So look at our table. Positive 3, 0 is our first coordinate without an error on it. So that means that that is our starting point, so that was good. So we did that right. So 3, 0. Then we have 4, 1. We go find some good ones. 7, 2. And we know we're not going to be able to go past 7, so I think that's okay. If you can graph it further, then you should get more points. So our first coordinate is at 3, 0. Then we have 4, 1. Then we have 7, 2. Again, we have no coordinates over here, so we're going to start at 3, 0 and connect our coordinates. Okay, so talking about our domain again, is going to the arrow is pointing to the right, so domain is left and right. The arrow is pointing to the right, so that's a positive infinity. But it's starting at your x value is 3. So close bracket, open bracket. Your range is pointing up, so that's also a positive infinity. And the y value is your 0, so we have a closed bracket and an open bracket. So again, it comes from your key point. So that's our domain and range. Talk about transformations. Transformations. Again, we look at our a equals a positive from here. It also equals a positive 1. Your h is equal to that positive 3, and your k is equal to 0. So transformations means that it's not reflecting, so no reflect, because it didn't cross over the x-axis, so that, it didn't reflect over the x-axis, so that means it's no reflection. There's no stretch or compress, because a is 1. But if you look at the graph, you can see that since h is 3 from 0, 0, it went right 3 spots. That's how you know that your transformation is correct. But it did not go up or down. So if we went from 0, 0, we just went right 3, and that's all we did. So all of our coordinates were just translated to the right 3. So those are transformations. To write it as a function notation, again, it would be f of x, because there's nothing in front. And then the negative 3, the minus 3 is inside with the x, so it's got to be inside with the x in the parentheses. Again, this just tells us that it's going right 3. That's all that is. Based off of the parent function, which was square root of x, it's just telling us that this is going right 3. Now we're going to do just 2 more examples on square root functions. The key point, we still always want to find the key point here. It's always your h and your k. You want to change your h and keep your k. So we have that negative 3 and a negative 1. That should be your key point, your starting point. So if we were to graph this, we go to our y equals, we have to type this in exactly as you see it. So the 2 square root x plus 3, they're inside the parentheses. So I have to close my parentheses and then minus 1. We're going to graph this. There's what it looks like. So we can see that negative 3 and negative 1 looks like where it's starting from. So we got to get coordinates. So second table. I'm going to go to the negative 3, negative 1, and everything else is an error, so that makes sense. So our coordinates, we're going to do negative 3, negative 1 is our first coordinate. Negative 2, 1 is the next one. then get some good ones. We have 1, 3 is a good one. Keep going, see if there's any more. We have 6, 5 is a good one. And that's probably going to be all that we can graph because the other ones are probably going to be too big for this graph. But if you have a bigger graph, you can definitely graph more. So -3, -1, -2, +1, 1, +3, and then 6, +5. And again, you have a starting point, so you don't want to have anything else over here. Now, if you notice, this graph right here is actually more like it's actually going up quicker than this first example. So this one, it looks like it's going quicker, so it's a stretch or a compress. If you look at your A value, you can tell that that is going to be a stretch or compress. So that actually does make sense that it's going faster. So our domain is still, is it going left or right? The arrow's pointing right, so that means you're going to have a positive infinity. And the x value comes from your key point, so -3. Closed, open. Your range is up or down, so the arrow's pointing up, so that's going to be a positive infinity. And it's from your y value of your key point, so -1. Closed, open. We still want to talk about the transformations. So if you look back at your A is still a positive, but now the A is 2. Your H is that -3, and your K is that -1. So since it's positive, there's still no reflect. But since A is 2, there's a vertical stretch of 2. You can see that from 0, 0, it did go left 3. And then it also went down 1. So even just looking at the graph, you can see that the direction that it went left or right, up and down, you can actually see from 0, 0, which direction did it go. So even if you don't know your key point, you can still see, or you don't know your H and K, you can still see that it went left and down. So you shouldn't get those wrong. Okay. Now for the function notation, again, you go back to your A, your H, and your K. So we have our A is a positive 2, so it's 2f of x. Your H is -3, that's inside, so plus 3. Close parentheses, because it's plus 3 right here. And the -1 is on the outside. So that's our function notation, because this goes for any function. This last square root one is going to be -1/2 square root of x minus 1 plus 4. So again, we always look for that key point. We change our H, get a +1, and then we keep our K as a +4. So again, even if you're not sure about that, you can at least look at your table. So go to y equals, we have -1/2, so parentheses -1/2, close parentheses, square root of x minus 1, square root x minus 1, close parentheses, and then we have +4. So we're going to press graph, and we think it might start at 1, 4. 1, 4 is where it looks, okay? Looks good. So we're going to go to our table. So 1, 4 is our first coordinate that doesn't have an error. So 1, 4 is what we put first. Then the next one, 2, 3.5 is probably going to be a good one to graph because it is a nice, easy coordinate. So 2 and 3.5. Keep going. We have 5 and 3. So we want to try and get as many coordinates as we can. Then the next one that we could graph would be, 10, 2.5. But again, so this is probably going to be too big for us on this graph, so if we only had these two coordinates, it would be hard to graph. But we at least do have the 3.5, which is a little bit easier. So 1, 4, 2, 3.5, 5, 3, and then we know 10 and 2.5 is way over there. So if we look back at our graph, we can see which shape it should go. It should be going this way. And if you think about it, the A was negative, and that makes sense. And then do you also notice that it's going a lot slower than the other ones? Because your A is 1/2. So it's actually going slower. So if we're talking about our domain, okay, which direction is our arrow going in, left or right? It's still going right, so it's going to be a positive infinity. And then the x value is the 1. So it's closed bracket. Then for our range, is the arrow pointing up or down? It actually keeps going down, and because our a was negative, that means we're going to have a negative infinity, and that is written first, comma. And then the y value is the rest of your range. So this time it's open bracket and then close bracket. So be careful about that. It's about where the arrow is pointing. Okay. The next is the transformations. So again, we need a equals a negative, a equals a 1/2, h equals a 1, and k equals a 4. So because a is negative and you see how it's going down, the range changed. That means that there is a reflect over the x-axis. A is a 1/2. That's a vertical compress of 1/2. Because h is 1, you can see that it went right 1 and then it went up 4. So even from, that's the 1, that's the 4. So right 1, up 4. Those are your transformations. So to write the function notation, we again use our a, h, and k. So it's just negative 1/2 f of x minus 1 parentheses plus 4. That's just your function notation. Because it's the same thing from here, just without the square root symbol. The square root symbol becomes your parentheses. So that's square root functions. So you can still graph them and look at the graph to see some of the transformations. So you should always get the translations correct.